Okay, good morning to all. Welcome back. So last class we have discussed about the swapping. So in the swapping, we have already discussed about rollout and roll in. So today is going to discuss what is backing store. Fast disks large enough to accommodate copies of all memory images for all users. This is the backing store, and must provide direct access to these memory images. And it must be large enough to accommodate copies of all memory images for all users, and it must provide direct access to these memory images. The system maintains a ready queue consisting of all processes whose memory images as scheduler and decides to execute a process it calls the dispatcher. And this dispatcher checks to see whether the next process in the queue is in memory. If not, and there is no free memory region, the dispatcher swaps out a process currently in memory and swaps in the desired process. It then reloads register as normal and transfer control to the selected process. So major part of the swap time is transfer time. Total transfer time is directly proportional to the amount of memory swap. That means when the swap out and swap in is working. Now when one process is required to enter into the main memory, but there is no free space in the main memory, so one process that means whose job is already is over or going to be over, it will be swapped out from this memory area and stored in the backing store area. And again another process which is want to enter into the main memory, it is swapped into that section. So next we are going to discuss about the virtual memory. So what do you mean the virtual memory? In the last class we discussed, it is a technique which allows execution of process that may not be compiled within the primary memory. It separates the user logical memory from the physical memory. This separation allows an extremely large memory to be provided for program when only a small physical memory is available. And virtual memory makes the task of programming much easier because the programmer no longer needs to worrying about the amount of the physical memory is available or not. Next, the virtual memory allows files and memory to be shared by different processes by phase sharing. It is most commonly implemented by demand paging. So this is the virtual memory. So let's talk about what is the demand paging. Demand paging system is similar to the paging system with what is the demand paging? Demand paging system is similar to the paging system with swapping feature. When we want to execute a process, we swap it into the memory. The swapper manipulates entire process where as a pager is concerned with the individual phase of a process. The demand paging concept is using pager rather than swapper. When a process is to be swapped in the pager guesses which phase will be used before the process is swapped out again. Instead of swapping in a whole process, the pager brings only those necessary pages into the memory. Right? So again I am repeating, a swapper manipulates the entire process, whereas pages is concerned with the individual pages of a process. Demand paging concept is using pager rather than swapper. When a process is to be swapped in, the pager guesses which page will be used before the process is swapped out again. So instead of swapping in a whole process, the pager brings only those necessary pages into the memory. Thus it avoids reading into memory pages, and that will not use any way decreasing the swap time and the amount of physical memory needed. In this technique, we need some hardware support to distinguish between the pages that are in memory and those that are on the disk. A valid and invalid bit is used for this purpose. When this bit is set to valid, it indicates that the associated page is in memory. If the bit is set to invalid, it indicates that the page is either not valid or is valid, but currently not in the disk. Right. So that is about all the demand paging concept. And next is your and this marking a page like to the what is the page fault. Page fault is a type of exception raised by computer hardware when a running program accesses a memory page that is not currently mapped by the memory management unit into the virtual address space of a process. Or you can say what do you mean the page fault? Now page fault is a technique through which when a processor requests for a page and the page is not present within that memory area or within that disk, that is the page fault. Right. So procedure to handle page fault, what are the page fault techniques are there? Now if a process refer to a page that is not page that is not in the physical memory, then we check an internal table or page table for this process to determine whether the reference was valid or invalid. If the reference was invalid, it terminates the process. If it was valid but not yet brought in, we have to bring that from main memory. Now we find a free frame in memory. Then we read the desired page into the newly allocated frame. When the disk read is complete, we modify the internal table to indicate that the page is now in the memory. Now we restart the instruction or system that was interrupted by illegal address trap. Now the process can access the page as if it had always been memory. So that is the procedure. So this is the page replacement, I can say how to replace the page. Each process is allocated frames which hold the process pages. Frames are filled with pages are needed. Over allocation of memory is prevented by modifying the page fault service routine to replace page. The job of the page replacement algorithm is to decide which page gets victimized to make room for a new page. And page replacement completes separation of logical and also the physical memory. So page fault means what means the page fault? Page fault means when a process required a particular page but that page is not present within that memory area, then it is known as the page fault. Right. So that is all about chapter number 3. So in the next class we will discuss about chapter number 4. So thank you to all.